All right, I think we're live. Hey, folks. Let's see. So we have some more people rolling in, but great to have you guys here. Um, my name is Milap. I work at Axelar, so I've been a core engineer there for a while now. I joined like Axelar like a year ago, and yeah, we've been yeah. Let me see. I'm checking if there's some comments. So yeah, I've been a core engineer at Axelar Network. My background has been in cryptography. I've sort of graduated from University of Waterloo, and I've been in the security space. And then last year, sort of like decided to venture into the crypto space. And yeah, it's been a great year so far. So at Axelar, like we are working on an universal sort of secure cross communication network. So let me share my slides, and then we can walk through that. All right. Yeah, so introduction to Axelar Network. We are a secure cross-chain communication platform. Uh, so yeah, so I mean, we have been working on building this decentralized overlay network that allows like users to transfer assets and like messages from one chain to another. And we're participating in the MIT sort of Bitcoin Expo Hackathon, and we're pretty excited to see what you guys build with our stack. So okay, give some context here. Initially, when Bitcoin started, like people were very excited about like the monetary application, and sort of the revolutionary monetary system that could be sort of envisioned through this network. And then later on, we saw Ethereum being created, and then people realized that you like by having this sort of world computer and an open platform that anyone can program in, we can have we can like allow like developers and sort of creators to build all kinds of interesting applications over such a system. And sort of over the years, we have realized that there are a lot of applications people are interested in, and then people might require sort of their own sort of decentralized networks or with specific requirements, specific benefits that they create so to launch their specific applications, right? So, for example, stable coins, like DeFi exchanges, and whatnot. So like we have seen a lot of new platforms from 2017 to 2020, and like it's really looking. It's like from this experience, it seems that we are going on a trajectory where we'll have a lot of different chains in the future that will be dependent that will be specific to different applications. This is sort of the multi-chain thesis that we here at Axelar believe in. Um, in this model of this multi-chain world, one of the problems that we have been seeing is being able to is being able to interoperate between these different networks. So in the DeFi sort of stack, what we've seen is that people are very interested in moving liquidity from one chain to another. Like for example, moving stable coins from one to another, so that you can allow swap, so users can swap for different tokens and whatnot. So due to this, so given this feature, we at Axelar wanted to build, we are trying to build this interoperability platform that allows users and applications to transfer assets and sort of messages from one chain to another. And we've already seen a bunch of interoperability platforms sort of pop up over the last year. Due to the user demand, we have seen a lot of sort of quick and dirty implementations of interoperability provide sort of bridges pop up in the last year, and that has had some sort of drastic implications, as we have seen in the last year. We've had like some very wide-ranging hacks, like the top. The four of the top DeFi hacks are sort of have been bridge related, and people have lost over $1 billion worth of funds through these hacks. So the first generation interoperability services, like they've introduced a lot of risk to users, and the architectures tend to always sort of go. The architectures have been using permission multisigs and which so permission multisigs means that there are like a 5 out of 10 sort of like there are 10 validators, there are 10 sort of stakeholders in the network, and they sort of just approve all the transactions when a transfer is being made from one chain to another. And this set is permission, so no one else can join. And and then it tends to be more centralized. Other issues we are seeing with existing interoperability solutions include sort of like pairwise connections. So there is no generic connecting tissue that connects all different chains. So as a result, there are like pairwise connections made between certain chains, but they don't scale. Like these solutions don't quite scale. I'm just going to stop and see if there are any comments in the meantime. Apologies for the. All right. So continuing on from that, let's see. So like from what we've seen in the Ethereum space, like developers building sort of decentralized applications, like they need like permissionless platforms to build their applications on, like not sort of siloed, like individual silos where that like the application just works in one specific instance for one specific tokens or something, or or it's sort of that restricts the application's user base and sort of functionality to a huge degree. So having a sort of open application sort of layer allows people to build all kinds of very interesting, cool stuff. So we really think that this is sort of how the interoperability space should also move, and the solution provider should match that. This is why the Axelar network is a permissionless network where any user can or any application can transfer any arbitrary message from one chain to another, and the whole flow doesn't require any approval from a trusted party at all. So the application is welcome to the application can do the whole flow themselves if they want to. So the Axelar network itself is based on sort of a proof of stake blockchain, similar to what we've seen with like Terra and Ethereum and Cosmos network. So Axelar uses the Cosmos SDK to build its network. And let me see. All right. Yeah, so as I mentioned, Axelar is a universal overlay network, and through this sort of decentralized proof of stake network we have like Axelar network allows sort of any validators to join permissionlessly as can be done in any other proof of stake network. And then Axelar provides sort of like routing layer that that allows connecting chains in a universal generic manner. So what this means is that suppose Axelar already supports, say there are like 3 chains already on the Axelar network. Say like Ethereum, Avalanche, Cosmos Hub, and then say through governance or through interest, 4th chain is added. Say it's Moonbeam. Now this chain is, because of the generic protocol, is instantly connected to all the chains that are already on the network, right? And this is a very powerful sort of design that applications can benefit from. Another sort of interesting thing about Axelar network is that we provide sort of translation and message passing at the core protocol layer itself. So at the moment, like this is like live on a mainnet. You can we provide translation between sort of EVM layer and IBC. So IBC being sort of the interoperability standard for Cosmos for the Cosmos ecosystem. So we sort of like first sort of natively support translation between this. So anyone can add, we can easily add another Cosmos chain, and now it's directly connected to all the EVM chains on the network, and vice versa with adding EVM chains. Finally, regarding security, so I already mentioned that existing like bridges, existing like solutions and whatnot, like they're really focused on permission multisigs. So they would have 10 sort of stakeholders that were selected by the like developer team, and they are the ones who just approve transactions. And in this model, we have seen a lot of like the consequences of hacks is quite drastic. So Axelar network instead is permissionless. So any validator who joins the network can participate in validating transactions that are being like cross-chain messages and transfers that are being made, right? So we don't have sort of just a small set of like whitelisted parties that get to be allowed to approve messages. So I think this is a very crucial sort of differentiating point of the Axelar network that makes it more decentralized and a lot more secure than other interoperability solutions. Okay. Okay, let's talk about the team a bit, right? So the Axelar network team, so it was founded by Sergey Gorbanov and Yurgis Lashos. They have deep roots at MIT, like they both did graduate studies at MIT, and they were also on the founding team of Algorand. And then other than that, like the other team members we have, like they have very sort of deep technical expertise in various areas like consensus algorithms, like cryptography, and just like design of protocol stacks. So we have a deep technical expertise that allows us to build this, the sort of future of sort of interoperability networks. All right. So okay, let's talk about the stack a bit. So how does the Axelar network actually work? Like, how do we actually allow sending messages between chains? So okay, let's start with the Axelar network. So the Axelar network, as I mentioned, is a proof of stake network that has a validator set that is permissionless. So anyone can join that validator set and receive delegations from users to have more stake in the network. Now, from this validator, so each validator who joins the Axelar network, they basically basically have run like nodes to the different chains we have on the network. So for example, Ethereum, Avalanche, etc. So each validator is able to read and read the state of the different chains they can support, and the validators get to decide which chains they want to support. They are not like there is no requirement that must support all chains that the network in general supports. So each validator has a sense of what the state of an external chain is, and through a sort of decentralized consensus, the Axelar network can basically get consensus on whether like a certain event occurred on an external chain. So for example, suppose you're a user and you want to say transfer some USDC from Ethereum and Avalanche. So the way it would work is that the Axelar network, so the Axelar network, you would just basically get a sort of deposit address on Ethereum that they can send your USDC to. Once you send your USDC to that deposit address, all the validators will essentially get consensus on whether the deposit was made. And once that consensus is obtained, then the Axelar network, like the validators, will sign off on commands on the Avalanche chain through our gateway contracts, which are these layer 1 gateway contracts that we deploy on each chain. And these will verify, this will authenticate the command that all the validators have signed, and basically transfer over the USDC to the recipient address on Avalanche for that user. To make so these core sort of, so these layers allow the Axelar network to sort of make the transfers, and then we provide developer tools at a layer above this, where the developers and users can interact with our SDK to do these processes in a seamless manner, right? So with one click for the user, a user can transfer a token from one chain to another. So because our sort of design allows for this very powerful application. All right, and we call this sort of the cross-chain gateway protocol, because it's sort of chain agnostic. It does the packet translation between networks, and it does delivery and sort of and all the routing. So really, the developer does not have to worry about the internal details about how that cross-chain transfers are made. All right, so let's continue. So okay, let's go over the first application. Okay, let's see. I think there's just checking comments. All right, so there we go. So let's talk about the first application is like universal asset transfer. So we would like the users would like to send assets between like multiple chains, um, and let's see how that would work. Okay, so we have to, we have this app like called Satellite, where you can find this at satellite.money, which sort of is a sample application through which you can see how a user can transfer an asset from one chain to another. The Axelar network, as I mentioned, so it offers sort of any to any routing, so a user can go from any chain on the network to any other chain in essentially what is a single hop. The translation, as again, happens at the network layer, so the user doesn't have to worry about that. One interesting point here is that all like the fees that the user has to pay for the transfer is just paid on the source chain. The user does not have to pay or interact with the destination chain at all. So the user might not even have a destination like native gas on the destination chain, and this would still go through. Also, all the user has to do is that the user will get a deposit address on the source chain through the Axelar network, and they just have to send their token on that, which can be done from any wallet. Right? The user does not need to have, say, MetaMask installed, for example, to leverage this functionality. Another couple of the cool properties about the network is that it takes like 10 minutes to like add another EVM chain because of the design being generic. And similarly, it's 10 minutes to add on the IBC chain, so any chain that supports the IBC protocol. All right. So okay, let's go get into the SDK. So the Axelar SDK has a bunch of core API methods that developers can use to make to sort of natively integrate the Axelar network into their applications. The first one is this get deposit address. So this I've already alluded to before, which is that say suppose the application wants to send a specific asset or say a token to a specific destination chain and a destination address from a source chain. So from these simple sort of parameters, you can query the SDK and sort of retrieve a deposit address on the source chain, and the user can transfer then the funds to this deposit address from any wallet, right? So you do not, as I said, we do not need the user does not have to MetaMask install or some specific wallet, right? The user can actually be on just a centralized exchange or some like third-party wallet that doesn't have much functionality except simple transfers, and they can just like transfer, make a normal token transfer through that wallet, and fees will be deducted from the tokens they're transferring, and the Axelar network will do the routing, and the funds will arrive at the destination at the end of it. Perfect. All right. So I guess another thing about the routing part is that the Axelar network itself only adds like very like minor latency to the transfer. It's about a couple of blocks on the Axelar network, which amounts to about like 5 to 10 seconds. In addition to sort of like the transfer time it takes on the source chain and then destination chain. So basically we are able to guarantee very minimal latencies through this design. All right. So this is one way that users can transfer funds. The other way is to interact directly with our gateway, smart contracts. So sort of going back to this model, right? So So we deploy these gateway smart contracts on all EVM chains we support, and a user or an application can directly interact with the gateway to send tokens to it. So, for example, like they can call the send token functionality, which will call the send token method on the gateway smart contract. And again, in the similar way, it will sort of route the asset to the destination address at the end of it. All right, quickly just check again if there is comments. All right, so let me continue. So okay, now let's talk about general message passing. Right, so token transfers, like that's been a big focus of interoperability networks so far is to transfer tokens. But we think that really just similar to how like Ethereum being allowing applications to sort of deploy any arbitrary code and allowing interactions between different sort of APIs, which led to this sort of massive interest in Web3. I think like message passing is where applications can do very, very interesting things cross chain. So let's see how we can actually use this with the Axelar SDK. All right, so yeah, so what is message passing, right? So similar to like on say an EVM chain, right? Like how an application, your smart contract can call a method on someone else's smart contract, right? Maybe say like execute a swap on like on Uniswap, and then like swap in the tokens and give that. So like that abstraction, we allow that to go cross chain, which means that a user, like your application, can be on Avalanche, and it can send an instruction to another contract on Ethereum, which will say swap say one token for another, and then maybe like forward that to a destination address on say like Polygon, right? So because we allow sort of smart contracts of like interactions between contracts on multiple chains, then you can do all kinds of these interesting applications, right? So as mentioned here, right, you can compose DeFi functions, like move. You can use because message passing allows sort of like the application to specify the payload. So saying that in the application can specify the instruction themselves, so then they can have a custom instruction of, as to what they want to do, right? So they can use this to even send NFTs between chains, and apart from just DeFi functions, and do other more interesting things. All right. So that's general message passing. So here's how the design works at the network layer. So suppose as a user application, right? You begin from the source chain. You have an application contract on the source chain that wants to send some bytes to another contract, say on the destination chain, right? So the way it works is that from the source chain, you will call this sort of call contract, and sort of like the send token execute, or like this call contract method on our gateway contract on the source chain. So again, to remind everyone, right, like on each EVM chain, we have these gateway contracts that allow applications to interact with the Axelar network. So on this gateway contract, you can call this specific like call contract function, and then to that you can specify the destination address, the destination chain, the payload you want to send, and as part of that, we have some fee services. I.e., there's a specific contract where you can send some fees to, and once you do that, we will pick up, like the Axelar network basically will pick up this transaction that you made and route it through the Axelar network to the destination chain, where on the destination chain's gateway contract that the Axelar network has deployed, this payload will be sort of lazily marked as approved, meaning that it's sort of approved by the Axelar network to be executed on the destination smart contract now. Now anyone can basically take this payload and now send it to the actual destination smart contract to let it be executed. But we do provide some, we have some infrastructure that allows this to be automated. So users don't have to deploy their own, and they can sort of get started right away. But it is a permissionless system, so they could do this themselves if they wanted. If they choose to use our infrastructure to do that, then they just have to pay us some fees to make up for the execution costs that we will have to bear. But the whole system is permissionless, so an application can decide to not actually pay fees to any third parties and route the transfer through the Axelar network themselves because of the permissionless system. Okay, and in through the when going through the Axelar network, basically, if a token transfer is being made, then as I mentioned before, then the Axelar network will subtract fees from the tokens being transferred, and then confirm and then sign. The validators will sign off on the transaction and confirm it. All right. Again, I'll just quickly check if there are any questions. Feel free to stop me if you have any questions in the middle. All right, so use cases. So what can you do with this cross-chain functionality, right? So here are some example applications, right? So first of all, we have seen the last 2 years just sort of the explosion in the NFT space and the DeFi space. With a interoperability network like this, you can build cross-chain NFT sort of transfer protocols. You can have a wallet that can do sort of borrow lending. So universal borrow lending. So you can use an NFT as a collateral to issue a token to a user, for example. You can use collateral from multiple different chains that are sort of IBC or EVM compatible on the network. You can do a cross-chain swap, for example. So a user has, say, some Ether on Ethereum, and they want some, say, like USDC on Polygon, and then through a cross-chain DEX that uses the Axelar stack, this can all be done in a single click. Which is just super powerful. So similarly, so you can do a universal sort of market maker, automated market making. So you can pool liquidity from users from any different chain, right, for any assets, and you can pool it through this application on any chain you want. Then there's sort of cross-chain synthetics. So you can call sort of data from so you can get data from other applications on specific chains to sort of index derivatives on the chain that you want to sort of deploy on. Then open gaming, so any asset anywhere sort of becomes currency or credential. So again, like it sort of allows provides more and more access to assets on various different chains. All right, so how do you get started with the Axelar sort of local dev setup? All right, so the so we have a GitHub repo that provides you that where you can actually just create a local dev environment that allows you to sort of test cross-chain functionality between multiple chains. The way it works is so let's see. So you can you can you can create your contracts and sort of deploy them on multiple sort of local chains. We will sort of simulate the relaying between the chains. And you can integrate this, fully in your front-end app and do a full local test for it. So here's the API for the send token, as I mentioned, right? So send token, you can sort of destination chain, destination address, provide the symbol of the token you're transferring and the amount, and call this on the gateway contract, and then we will send the token to the destination address. Okay, the API for the call contract looks like this. So you can specify a destination chain, destination smart contract address, the arbitrary payload that you want to send, and then we will relay it. So the way a remote contract relay works is that, as I mentioned, that the gateway on the destination chain only approves that execution can now take place. So what an application needs to do is that they need to, on the destination chain, sort of implement this executable interface that provides this execute API. And in this execute API, basically, the application can expect the source chain, the source address, and the payload that is being sent, and then they can process it in the way they see fit. This is the executor. This is the function, like the execute function on this interface is what gets called by the executor services that Axelar provides for the fees like which require the fees to be paid on the source chain. All right. So here's an example of Zen token. You can import the Axelar local sort of gateway repo, and then you can spin off like two networks, the two local networks, provide say some USD token to the user on the source chain, and then all you have to do is call send token um, from on the gateway contract on the source chain, right? So on the chain once gateway contract that Axelar is deployed, the user just has to call send token and provide the destination chain and the destination address and the token and the amount. And now they just sort of wait for it and then simulate the relaying of the transfer by Axelar to make the call happen. Cool. All right. So and then going back to this Axelar executable interface that a destination app contract has to implement, right? So this is how it looks like. So an executable like an application just has to implement this interface and implement this method. And this method, the application gets to decode the payload in the way they see fit and process it appropriately. All right. So similarly, like you can see an example here, right? So you can say create two networks, source and destination chain. Say deploy a contract on the chain one to do the setup. And now let's do a remote contract call, right? So the source chain encodes a payload in the way they see fit, right, based on their sort of format, which is in this case just a UN256. Then connecting to the gateway smart contract on the source chain, the application can call the contract, provided the destination chain, the destination address, and the payload, and then have Axelar relay the call. And then on the destination chain, it will be executed by the executor services that we provide. And then you can see on the contract that this value was received, right? So it was set to 1234 as implemented here, right? So this application contract set the value to the received payload. All right, I'm just gonna look. All right, so yeah, so use all right, so the contract was made and the payload was received. Now let's take a look at the example. So this functionality for message passing is already sort of available. So while you can do this locally, it's already available on our testnet and mainnet, and you can deploy this pretty quickly already. And you can find some examples or like some example applications on this repo. So it's like Axelar local GMP examples. All right. And then going to the bounties for the hackathon, right? We'll be providing a total of $5,000 worth of bounties. The first prize will get $3,000 and $1,500 and $500 respectively. And some sample ideas already mentioned, right? Users can build a cross-chain DeFi platform that allows anyone to swap from different chains for an asset they provide. Users can create a multi-chain wallet, such that a wallet that allows sending any token to any sort of destination chain that the Axelar network supports, and then the users can also application like for the hackathon, like example projects can be like to do cross-chain NFT transfers, and there are some examples like mentioned here that showcase like how this would go about. And of course, as you'd expect, like your project for the hackathon to qualify for this must use the Axelar network and have a working prototype at the time of being submitted. All right, and then if you're like to incentivize this further, and sort of if you are if you from the hackathon experience, or if you want to spend more time on this, we have a grant challenge where we want developers to build a super sort of decentralized app that that's unique and cross chain that hasn't existed before, and we have various grants for this. So we are giving a lot of we are giving like grants for 20K each, and like initially it was just 15 grants, but in fact that we are like doing it on a rolling basis now. So we'll just determine based on your application and sort of like how great your application is, like how well it integrates the Axelar network, and that would be the criteria. So this cap is sort of removed for now. And then based on the grant, like the different applications we get, like some of like 5 of them, we will sort of invest 200K in them, and then even out of those like 5, up to 2, we will invest 500K in that. So we're pretty excited to see applications. So feel free to submit your applications that you build to our grant program. All right, so apply now, and please look at our docs. So it's docs.axelar.dev, where you can find all kinds of resources about like how to integrate the Axelar SDK and other questions. And then on Discord, feel free to reach out to me or any of us to ask questions and just interact with us more. All right, awesome. So that's it. I'll open it up to questions. I'll be around during the hackathons in person over the weekend. So please come say hi to me, and it'll be great to interact with everyone. All right, so I'll stop sharing my screen in the meantime. All right, yeah. So if you guys have any questions, please drop them in the comments, and I'm happy to answer them. Otherwise, I'd be happy to see you guys in person during the hackathon, and we can chat more about this. All right, so I'll wait for questions. Yeah, I see a comment about like we need to approach. Yeah, we definitely want to approach more and more people. We have a very growing community on Discord, so like please join. You can join that and interact with all kinds of people there. And it's definitely you're growing pretty fast. So come join us. All right. Yeah, I don't see any more questions. I'll give it a minute, and then maybe we can close it off. All right, so I think I'll close it off here, but I'll definitely be available on Discord and during the hackathon, so please ask me any questions. All right, folks, it's been great. Hope to see a bunch of you there. All right.